guys, welcome to class. We're studying our new unit today. I haven't finished grading your test yet, but don't worry. The ones I've done so far, you all have been great because you're model students. So our new unit is electricity, okay? And what do you guys know about electricity? Like, have you heard about it? What things are electric? Give me some feedback here.
When you stick your finger in the light socket, it doesn't feel very good.
It doesn't feel very good? What does it feel like? Have you done it?
It's tingly.
Tingly? Awesome.
And hurts.
Okay. Do you think your light socket's like as bad or worse or less than like a lightning strike?
Lightning strike's probably worse,
Probably
I would
worse.
think.
That's a lot of electricity. Okay. Well, as you guys probably know, everything around us is somewhat electric. Okay? And we're going to explore that today. We're going to see how things are electric. So, if you guys can kind of take a seat, we are going to build electricity detectors using tape and a little piece of paper, which I'll get for you.
There's a piece up there.
Ooh, sorry.
It just needs to be a little bit. Okay, so I want each of you to pull off 2 pieces of tape and stick them on the end of the table. Okay, we're going to make them a little different.
Got one for you.
Thanks.
Okay, so I'll do 1, 2 so you can see what to do. Okay. So with your pieces of tape on the end of the table, I want you to take one end and just fold it over flat, making a little tab that you can hold it on that's not sticky. Just fold it flat over like a rectangle. And the other piece, I want you to fold the corners in to make a triangle on one of the ends.
This is technical. This is
Hmm?
technical.
Yes, it is. Okay, so now what we're going to do is we are going to charge the tape, okay? We're going to take the pointy piece of tape and put it sticky side down on top of the smooth side of the rectangle tape, the base tape.
So like smooth, sticky, smooth, sticky.
Mm-hmm. And rub them together, get them good and tight. Yeah. Okay, now what you're going to do is you're going to take those 2 pieces and pull them off of each other super fast. Okay, awesome. Okay, mine kind of curled around on my finger, I don't know if you saw that. But what you're going to do is put one end on each piece of paper. So take the pointy one, stick it on this end. There you go. And take the flat one on the other one. Okay. I'll leave mine here for now. Now what we're going to do is we're going to balance that piece of paper. We're going to use this styrofoam cup as a stand. So we're going to balance that piece of paper. I'm going to like fold it a little bit for you. There we go. Okay. Actually, let's do it this way. I think it'll balance better on the point. Okay. Hopefully that does it. Okay. Now, we need to, this is our detector. It's going to point towards or away things that are electrically charged. Okay? So now it's up to you guys. I want you to bring things around, bring them, charge them, whatever you want to do. Bring them close to your tape and see if it moves around. For instance, I can take styrofoam and this clear acrylic. You can do it on the styrofoam. There you go. Move it towards it. Oh, you totally moved it. It's an electric compass. If I bring this near. Oh, it's not wanting to move too well. Maybe I didn't charge it well enough. You got a better charger system going on. Okay? So it'll take about 5 minutes and find objects that make the compass move.
This one makes
Things
it
that
move.
don't. You guys ever done like a balloon where you rub it on your hair and then it sticks to the wall? Yeah, that's another example of electricity. wonder if that one's just not very movable. I wonder.
There you go.
Yeah, there you go. Nice.
That worked.
Oh, you got the back end to move too. Very cool.
She may pick it off her face.
You can try my keys, just not my flash drive, because I don't want to lose any data on it.
I made a move.
Hey! Alright, now as you're doing this, now you kind of got the hang of it. Kind of group the themes. Themes that make it move really well, themes that make it not move super well. If you need to write them down in your lab notebook, you can.
These worked.
Ooh, we got some carpet rubbing going on. Oh, you got more tape. Tape makes it move. Oh, it looks like the pointy end is really attracted to that piece of tape.
She wanted this piece of tape.
Yeah.
Oh, and that other piece is repelling it? Very interesting. Okay, guys, let's wrap it up, our exploration for a little bit, and come back together. Can one of you guys tell me what the coolest thing you did with your thing was? Lexi? The tape?
I did the same thing with the tape. One piece would make it move away from my tape, and my other piece of tape pulled it towards it.
Interesting. Now, do you remember which piece of tape was on the top or the bottom when you pull them apart? We could do it
This piece
again.
was on the top.
That one was on the top? Alright, and that's the one that repels the pointy end? Okay, so the pointy end was on the top when we made the compass. Do you remember that? So what can you say about things that are the same? Do they attract or repel?
They repel.
They repel. Okay. And then things that are the opposite. So the piece of tape that was on the bottom, did it attract or repel the pointy end of the tape that was on top?
It tracks it.
It attracts it. Weird, huh?
But it did at one point.
That's really cool. What other objects worked? Did you find anything else that made it move around really good?
Styrofoam did.
Styrofoam, did it attract or repel the point?
Tracks.
It attracts it. Very cool.
This weird spongy thing attracts
The spongy thing attracts it?
Did you want it?
I don't remember. I would really rub the side of it or something. Why do we have to rub it?
That's a really good question. Do you have any ideas? So, okay, so the plastic attracts it. Did anyone try the clear acrylic plates?
It did. It doesn't really work.
What you talking about?
Looks like it's attracting it too.
Specialty.
What about if you rub the styrofoam on the acrylic plate? What would that do? The styrofoam attracts the pointy end?
Yeah, the styrofoam attracts the pointy end.
Oh, really? That's super weird.
And,
And now the acrylic's
plate.
repelling.
Oh, that was a good one.
So it depends on what you rub it, whether it's going to attract or repel, right?
Right.
Cool. All right. Cool. So can you guys draw any conclusions from this activity?
Something is making it move.
Something's making it move. That's a really good start. Let's see if we can make that a little stronger scientifically, okay? What's the something, do you think? Do you have a hypothesis about what the something is?
Static electricity.
Static electricity. All right, so like the lightning strike we talked about at the beginning of the class, or like when you rub a balloon and it sticks to the wall, that kind of a static electricity. When you rub, yeah, we're gonna do that a different day. We're gonna experiment with how much charge we can put on stuff, okay? Okay, hang on, we'll get to there. Alright, so I need you guys to all get out your lab notebooks, pretend lab notebooks, and write down a good hypothesis, okay, for what's making our little compass move, based on what you know about objects and their charges. Awesome. Does anyone want to share their hypothesis?
I already said mine,
Okay.
so you can share yours.
I said that if the object has electricity or an electric force in it, it causes other objects to repel or attract.
Very nice. That's really good. Can you guys think of a good way to test some of your hypotheses? Using our new electric detector.
Well, we could record which objects make it move away and which ones make it move towards it.
Okay. And we could use that to find out which ones have which kind of charge. That's really good. So actually scientists call the two kinds of charge positive and negative. And if an object's positively charged, it will attract the pointy end of the tape. And if it's negatively charged, it will repel the pointy end of the tape. All right. So based on that, can you tell me which of your objects are positively charged from our activity we did before? This is good stuff to write down in the observation section of our lab notebook.
Is the pointy tape positive or negative?
The pointy end is positive.
So styrofoam is negative,
Because why is it negative?
because the point sticks to it.
Okay, so positive and negative are opposites, and opposites attract, right? That's what the styrofoam tells us because it attracts the pointy end of the tape. Awesome.
And when you do the styrofoam and the acrylic, the styrofoam is negative. And the acrylic is negative? Maybe? Doesn't seem right. Hold on.
Rub it really hard. Sometimes it's hard to get this to work well. Especially on days like today when it's super rainy, sometimes the air makes the charge leak off.
Okay, the styrofoam is the negative,
Hmm.
and the acrylic plate is positive.
Awesome. And how do you know that, Lexi?
Because the pointy side is positive, and the acrylic plate must be positive in order for the pointy part to move away from it, because they repel each other.
They repelled each other. Awesome. That would be something really good to write down in your observations of your lab notebook. Okay. Does anyone have any questions? Oh, I forgot. We have one more thing to do before we wrap up class today, and that is to draw force diagrams for our piece of tape. So, when you guys hold this.
Force diagram. What's a force diagram? I don't remember.
You don't remember force diagrams? Lexi, do you remember? Dr. Charles, what a force diagram is?
Kind of. So a force diagram shows what's acting on a particular object. So you can draw the arrows coming out.
Okay.
Looks like a pencil.
So this is our piece of tape. I know it looks like a pencil. Okay? So here's the pointy end of the tape, and here's the rectangle point part of the tape. And remember that the pointy end is positive, the other end is negative. Alright, so if I bring the acrylic plate close to the pointy end of the tape, okay, can someone help me out? What is the acrylic plate going to do to the pointy end? Is it going to attract or repel?
You pushed it away.
Push it away, so it's going to repel. So what direction am I going to draw the arrow for our force diagram?
Down.
Down, because it's pushing it away. Awesome. Okay, now what if instead this was styrofoam? It would, it's going to attract or repel the pointy end of the tape. Attract. Okay. And what's it going to do to the negative end of the